Hi, grade 11 class. Let's talk about domain and range today. So this is lesson 1.4, which you can find in under Unit 1 in our class website. Okay, so here is an example 1, which says state the domain and range of each relation. So you'll notice that these relations don't necessarily have equations associated with them. In this first one over here, in fact, I only have points. I don't even have a line. But you should probably still ask yourself, is this a function, right? Because functions and relations can be represented in a variety of ways, right? So if I'm looking at this graph, suddenly I can see that, hey, there's 2 points over here that have an x value of 2. So since there's 2 points with an x value of 2, right, I have 2 different y values for the same x value. That means this fails my vertical line test, right? It fails the vertical line test, so it's not a function. And that's just something that we should keep in mind during this unit. Is the relation we're looking at a function or not? It's good practice in general, but we can still state the domain and range of a relation even if it's not a function. So when I'm given just a set of points like this, stating the domain is just a matter of stating what x values I have for these points. So my domain is an x value of -1. I have an x value of 0, an x value of 1. I have 2 under an x value of 2, but I only have to state it once. And I have an x value of 3, and that's it. Then I look at my range. I look at my y values. So I have 2 under a y value of 1. I have a y value of 2, a y value of 3. Actually, I have 2 under a y value of 3, but I only have to state it once. And then I have finally a y value of 5. So I don't need to necessarily state, I don't have to write, for example, that y is between 1 and 5, because it's not between 1 and 5, right? I don't have a y value of 1.5, for example, right? So since these are just points, I don't state what is in between the points. I'm just listing the y's that exist at that point. Okay, so let's look at actually identifying for a line. So when I'm looking at this line, what I'm really doing is I'm asking myself, is there any number that x cannot be? So when I look at this, it looks like x is just existing for every number that's visible. And I'm going to assume that it's just going to keep on existing in this direction forever. And I'm going to assume it's going to keep existing in this direction forever. So really, all I have is x can be any real number. And that's how I write that. I say x is part of the set of all real numbers. And similarly, if I'm looking at my range, well, it's going forever downwards in this direction, and it's going forever upwards in this direction. So I have a range of y, part of the set of all real numbers. Okay, so what does it look like if I'm dealing with something called an asymptote, right? Asymptotes are lines that approach a curve but never meet it. So they are represented by broken lines, often with arrows on the end. So here I have an example of a relation. This one's actually a function, right? It's a function because it passes our vertical line test. It doesn't look like there's any x values that have 2 y values. So here I have a function that has 2 broken lines on it, right? It has 2 asymptotes. One of them is a vertical asymptote here, vertical asymptote at x equals 0. And I have another one that's a horizontal asymptote at y equals 0. So what I'm doing is I'm going to look at all of my other numbers, and I ask myself, okay, well, in my domain, I already know that x cannot be 0. I already know that I have this curve, and it's never going to approach 0 because that is part of the definition of an asymptote. It never meets 0. So this line is never going to cross 0. It's just going to keep going down, down, down. It might get closer and closer and closer to this dashed line, but it's never really going to cross it, right? And similarly, when I look over here, it comes from a large number, and it might have been close to 0 over here, but it's never really crossed 0. So I can write that out as x is part of all real numbers except 0. So I write that as x cannot equal 0. So it's every number except 0. And then similarly, I can look at my range. So the range is pretty much the same idea, right? It's getting closer and closer to 0 horizontally from here. It's getting closer and closer to 0 horizontally in this direction, but it's never actually going to cross it. It's never actually going to cross that line. So y can be any real number except y cannot equal 0. Let's do some more practice. What about lines that are kind of broken and connected together with open dots and closed dots? What does this mean? So here I have a horizontal line that starts at -5. I think it's kind of hard to see on the camera. But here I have -5, a closed dot. So that means my function is present at this dot. And then it goes over to -2. And over here, I have an open circle, right? So if a curve is undefined at a point, we use the representation of an open circle. So that means that at this point here, it's not defined. So I have an open circle here at x equals -2, and I have a closed circle here at x equals -2. So that means the function, or sorry, the relation in this case, because I don't know if it's a function yet, it does not exist here, but it does exist here. So technically, this currently passes our vertical line test. So even though I have something here and something here, it's not defined at this point, and it is defined at this point. So that means so far we're passing our vertical line test. Let's keep going. It continues down this way, and then I have an undefined point here, which is connected over here. So this also passes our vertical line test, and then it continues over here. So this is actually a function. So this passes our vertical line test, and it's a function. All right, so what is the domain and range of such a function? Well, since I do have lines here, it's not just points, I do have in-between points, right? So that means I'm going to be using less thans and greater thans in my domain and range because I have these lines, not just points, right? So I know that my domain is going to start off with real numbers, so x is going to be part of the set of real numbers. But I see over here that x isn't necessarily all real numbers, right? It looks like x is actually starting over here, right? Because I have a point here, and it looks like x isn't really continuing before that. So this is my minimum x. So I have a minimum x of -5, right? And then over here, I have a maximum x of 6. So I have a max x of 6. And it is defined at both of those points. So min x of -5. So that means that I have -5 as my smallest number, and x has to be greater than or equal to it. And then x is smaller than or equal, so it's smaller than or equal to 6. And the reason why it's smaller than or equal and not just smaller than is because we do have these closed points here, right? So that means that I can have an x value of -5, right? So it can equal -5. It's also bigger than -5, right? Because x exists in between these 2 points, right? And similarly over here, x can equal +6. So I have an equal sign over here for a +6, but it's also less than. So x is less than and equal to 6, and it's greater than or equal to -5. So x is kind of just in between of my minimum over here and my maximum over here. Let's have a look at the y values. So when I'm writing my y values, similarly, I see that y can exist in between here. It's got these lines connecting it. So once again, I have the knowledge that y is part of the set of all real numbers, right? And what I'm going to do is look over here and see that I have a minimum y of -3. And here, if you notice, at this minimum, y doesn't actually exist, right? So if I'm writing it out, I have -3 is less than, but not equal to y, right? Y cannot equal -3, so it has to be bigger than -3. And then over here at +3, I have a maximum value of y. So I have a maximum y of +3, and it looks like I have an undefined value over here with this open dot, but I have a defined value over here with this closed dot, and another defined value over here of this closed dot. So since my max of y of 3 here can equal 3, it equals 3 here and it equals 3 here, it doesn't matter that it's not defined here. So that means that y is going to be less than, but it can also equal 3 as well. And then I close my brackets, right? So I have y is between -3 and +3. My minimum value is over here, and my maximum value is over here. Now, keep in mind that you don't have to write this min and max here, right? So if you wanted to just write XER, -5, less than, greater than x, less than, greater than 6, that would be done. And with the range, you have y is part of all real numbers, -3 is less than y, less than or equal to 3. And using our curly brackets to open and close the domain and range. All right, so let's look at some more examples here. So I have the example, y equals -5, x plus 3 squared plus 4. So if you remember from graphing our lovely vertex form equations, right? I have a vertex here of -3 and +4, right? So if I'm graphing that out, I have a vertex here of -3 and +4. And my a value is -5. So using the step pattern, I have -5 times -15 would be my second step. So if you remember, it's 1a, 3a, 5a, 7a, etc. is my step pattern. And that is what I'm going to use. And I don't really need to do 5 times -5 because I don't think I'm going to get much further than that. So that's what I use to graph my equation. So I have my first step is -5. So I go down 5, 1, 2, 3, 4, 5, and over 1 on both sides. And then I'm going to go down 15. I don't think I'm going to quite reach it. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I didn't quite reach it. So my graph is like this, right? My parabola looks something like that. So if I'm looking at this, my x isn't really limited, right? It's going to keep going forever in this direction, but I can plug in any x value and I'll get a y value, right? However, there's no x value that I could plug into this equation to get a y value that's bigger than 4, right? My y value is always going to be 4 or less. So when I'm stating my domain and range, so that means I'm going to have a domain over here of just simply x is all real numbers, right? And my range is going to be also part of the real numbers, but I have this limit. Y has to be less than or less than or equal to 4. So it's kind of like I'm looking at the y value of my vertex here, and that's really the limit on my y. So this is my limit of y. And since I'm looking at a parabola that's facing down, this is my maximum limit. This is my maximum here at 4. So since I have a maximum of 4, that means my range has to be less than or equal to 4. Let's look at an example of a square root function, right? So here I have y equals the square root of x. Well, I'm just going to start off with 0, 0, right? Square root of 0 is going to be 0. However, I got to ask myself, can I put a negative number under the square root? If you remember from learning about square roots, we know that that doesn't really exist in our set of real numbers, right? So no, I can't put a negative number under the square root, so that means that 0, 0 is really where my function starts. After that, I can do 1. Square root of 1 is 1. Let's go skip over to 4. Square root of 4 is 2. Skip over to 9. Square root of 9 is 3. And here I have this function. Kind of looks like half a parabola turned on its side, right? And this is a square root function. So when I'm looking at it, I have this limit where x has to be bigger or equal to 0. And similarly, y also has to be bigger or equal to 0. So that means my domain is x is part of all real numbers, where x is greater than or equal to 0. And my range is the same thing. Y is all real numbers, where y is greater than or equal to 0. Right? Let's look at x times y equals 10. Well, if I have an x value of 1, right, that means I have a y value of 10, because 1 times 10 is 10. 2 times 5 is 10. 5 times 2 is 10. And 9, 10. 10 times 1 is 10, right? So I have this line that kind of curves in both directions that way. And then I have to ask myself, can I have x or y ever equal 0? Is there a number that I can multiply by 0 to equal 10? No. So that means I have this line here, and I'm never going to have an x value of 0. And similarly, I'm never going to have a y value of 0, right? Because y, I can't multiply, if y is 0, I'm not going to get the number 10. And if x is 0, I'm not going to get the number 10. So I can't have a y value of 0, and I can't have an x value of 0 for this statement to be true. So now let's think about negative numbers. So if I have x is negative 1, that means y is going to be negative 10. And similarly, if x is negative 10, y is going to be negative 1. If x is negative 2, y is going to be negative 5. And if x is negative 5, y is going to be negative 2. So it's kind of like I have this mirror over here of this graph. So when I'm looking at it, it looks like x can pretty much be any number, but it cannot be 0. So when I'm writing that as my domain, I have x as part of all real numbers, but it can't be 0. And similarly, y can be part of all real numbers, but it can't be 0. Okay, let's look at one more example. Here I have a nice linear equation, which you might remember from grade 10, right? So I have a linear equation with a slope of 2 and a y-intercept of 5. So when I'm graphing that, I start with my y-intercept of 5, and I'm going to go up 2 and over 1 with my slope. And I can do the same on the opposite side. But whoa, what's happening here? X has to be bigger than 7? Okay, did I write that properly? X has to be bigger than 7? I guess so. So if x has to be bigger than 7, it's not actually going to appear on my graph. So let's just change the number a little bit. Let's make it x is -7 over here, just so that I can show you on my graph what that looks like. So x has to be bigger than -7. So if x is -7 over here, so if I continue my line going down 2 over 1, just continuing my line and being lazy and not actually computing. It looks like here, when x is -7, this is actually where my line starts, right? So here I have this line that is going to start at an x value of -7 and continue from there, right? So it's going to continue forever in this direction, but it's not going to continue before this point, right? Because x has to be bigger than or equal to -7. And I just changed that number in the question so I could draw it on my graph. So x has to be bigger than or equal to -7 over here, right? So that means my domain restriction is kind of given to me in my question, right? So I have a domain of x is part of all real numbers, where x is bigger than or equal to -7. And my range, I have to think, what restrictions does that place on my range if my x has to start at -7, right? So my range can go forever upwards, right? Similarly with my x, but before this x of -7, it can never be lower than what looks like -9. So what that looks like is I have y is part of all real numbers, and y has to be bigger than or equal to -9. Okay, so your homework for this lesson is on page 35 in your textbook, numbers 1 to 5, 10AB, and number 14.